All right, hopefully this video will help you since I am not available there to answer questions. So we're gonna do some review and that's just gonna be the way it is. So for this first one, we are just doing a qualitative sketch, path of the rays as they pass from air into the water. So the first thing I wanna ask is which has a higher optical density, air or water? And of course, the answer is water has a higher optical density. So what's the first thing we do when we are figuring out where the rays go? And the first thing we're going to do is draw the normal. So I'm going to draw a normal here. Now, we know that we're going to think about Snell's law. N1 sine theta 1 is equal to N2 sine theta 2. Just a 1 there. And the first thing we need to do is that N1 is the air. And I want to know what is, for this first ray here, what is the angle theta. And the angle theta is 0 because 0, remember when we're doing our protractor, that's not working, we start with like 0 and then we go 10, 20, 30 and so forth down to 90. And same thing on the other side. So this angle theta 1 is 0. And the sine of 0 is 0. So there's no bend, and so this arrow just goes straight through. All right, so first thing we do when we are trying to figure out where this ray goes is we draw the normal. Oops, a pen. I'm gonna go in a little bit closer. Okay. So the question is, if I'm going from air into water, so into from lower to higher optical density, is my refracted ray going to bend towards the normal or away from the normal? And the answer is it's going to bend towards the normal. So I look at this angle here, and my refracted ray, or theta 2, has to have a smaller angle. And so we have options. It could either be this angle, because that's smaller, or it could be this angle. So which is it, A or B? And the answer is B. As I talked about yesterday, my angles are going to go, or my rays are going to go to the right of the normal. It's not going to like turn around and go backwards. So that is wrong. Okay, next ray, we're gonna do this one. So towards or away, or what's the first thing I do? Draw the normal. And again, this is my theta 1. Is theta 2 bigger or smaller than theta 1? It's going to be smaller. It's going to go this way. And so that is going to be my theta 2. Next ray. Same thing, draw the normal. Now, if you haven't done it on your paper, I want you to stop the video and draw it right now. Okay, so this is my theta 1. My theta 2 has to be smaller, and it's going to go that way. So hopefully your theta 2 looks something like that. All right, next one. Now the light source is underwater. Sketch the path of the rays as they pass from the water into the air. So are they going from high to low or low to high? And the answer is the rays are going from higher to lower. And so does that mean rays bend towards the normal or away from the normal? Well, first of all, anything that comes head on just goes straight through. So that one we don't even need to think about. towards or away from the normal. So first thing I'm gonna do, so I've got 3 directions that the ray could go. It could go here, it could go here, or it could go here. Where does it go? A, B, or C? And the answer, it goes to B. And then we'll do another one. Okay, now this is if the ray went straight through without having any refraction. Is it going to be A or B? And the answer is B, because it has to bend away from the normal. So this is no deflection. This would be towards the normal, and so this is away from the normal. So it goes like that. And for this one, we're not really doing numbers. It's just qualitative. All right, let's do another one. So we've got here, where does it go? A, B, or C? The answer, it goes into B. And then I'm gonna do the same thing that I did before. So if it doesn't refract at all, it would go straight through. So I'm gonna do a different one. Is it gonna go X or Y? It bends away from the normal, and so that is gonna be Y. And again, we're just kind of doing this qualitatively. Last one. I'll do the same thing. Is it going to be A, B, or C? The answer is it's going to be in B. So again, if it doesn't refract, it would just go straight through. So is it going to be X or Y? And the answer is Y, because that's bending away from the normal. So this is no bend, and then this is bending towards the normal. Okay. So, all right, next one. Qualitatively sketch the path of light rays as they go into the glass and then exit the glass. So these are all making a 90-degree angle. So what do we know about the path of the light? And what we know is that it's going to go straight through. So straight 90 and then straight 90. So it's going to do that. Same thing here. And the reason it's going to do that is because theta 1 is 0, and the sine of theta 1 is 0 degrees, or is 0. Okay, next set. What's the first thing we're going to do? First thing we're going to do is draw the normal for this first block. Again, I want to ask you, is the ray going to go for, I'm going to do different letters. Is it going to go M, N, or O? And the answer is it's going to go to N. And then we can do this. So if it doesn't bend at all, is it going to go to 1 or 2? And the answer is going to go to 2, because I'm going from, this is low, this is high, and so I bend towards the normal, and that's this side. So it's going to go like that, and we're going to go to the other side until it stops and hits another boundary. And then we repeat the process. So where it hits the boundary, we're going to draw another normal. Okay. I'm going to make this ray black so we know that that's the light. So that is the light going through. And again, we'll mix it up a little. Oh, I was doing dark green. So let's go Q, R, and S. So where's the light going to go? Q, R, or S? Now, some of it will go to Q, but for our refracting, we will go into R. And then do the same thing we've been, so this is if it doesn't refract at all. Am I going to go into X or Y? And the answer is I'm going to go into Y because I'm going from high to low. This is my index of refraction. Glass is higher than air. And so when I go from high to low, I bend away from the normal. And that is what it will look like. It actually will exit more like, more like that. Sorry, I keep doing that. More like that. And these rays I can copy, and it's going to look the same because the rays coming in from the air, those are all parallel to each other. Oops, I need to move this over. These rays are all parallel to each other. And so that means these rays all have to be parallel and these rays all have to be parallel to each other. Okay, so that is, we've got some more complex ones. So we're gonna do the same process. So back to blue. Now, again, we're gonna draw a normal. The normal looks like, whoa, I'm gonna pull my roller out. That is the normal. And while I'm here, I'm gonna do this one as well. Oops. So you may wonder how I'm doing this. If you, let me draw this first in case it goes away. All right, so that's my normal. See that line there? Nope. Interesting. My highlighter is not coming up. Yeah, it's just not gonna come up. All right, that line and that line, I just like made a straight line with it. So, all right, so that's how I drew the normal. And then we're gonna play our game again. Am I gonna go to A, B, or C? And the answer is I'm gonna go to B. Here's where it gets a little bit tricky. That's my angle of incidence. And am I gonna bend towards the normal or away from the normal? And I'm gonna bend towards the normal because this is low, this is high, this is low. So again, I'm gonna do this little trick just because I find it easier to like draw my angle. So this is, if it went through without being deflected, it just goes straight through or without being refracted. And since it bends towards the normal, I know that it has to be more like, oh, it's gonna just like go along the line. I'm gonna move this down a little bit. So, okay, I know that it has to be between the normal and that straight line. I'm gonna draw it all the way over to here. that's where it hits. Same thing. Draw the normal. And I'm gonna do my normal. Okay, towards the normal or away from the normal? Here's also where it gets a little bit interesting. So is it going to be M, N, O, or P? And the answer is it's going to go to N. So again, if it was going to go straight through, it would look like this. Am I bending towards the normal or away? And the answer is I am bending away. And so away is going to look like that. Because remember, the normal is this line. It's not going to go over. Yeah, it's not going to go over there. It's that line, and I need to, this is no refraction. This is bending away. And so that is where my line is going to go. All right, keep doing these. So you'll do a similar process for the lower half and for here. Draw the normal, do the first ray, goes all the way across, then do another normal, draw the second ray. Make sure that you are going into the right quadrant and that you're bending towards or away from the normal.